Alright, so in this video we're going to discuss collisions of carts and conservation of momentum. For this problem we're going to have an initial velocity of the red cart, which is here, has a mass of 1 kilogram and the velocity of 6 meters per second. Over here, the blue cart, we're going to have a mass of 3 kilograms and an initial velocity of 2 meters per second in the other direction. We're going to have an elastic collision, which means that after the collision they're going to separate, they're not going to stick together, and we will see exactly what their velocities change to after the collision. So we're going to start this animation, and initially we see that the carts start to go towards each other. The red cart 6 meters per second, the blue cart negative 2 meters per second. Again, it's negative because it's going in the opposite direction of the red cart. The red cart we chose as a positive velocity, which is in this direction, the right direction. The blue cart is going left, so we have to make it a negative 2 meters per second. The collision happens. You can see that they separated on impact, and the red cart goes towards the left at negative 6 meters per second, whereas the blue cart goes to the right at 2 meters per second, as you can see. We'll show it again in fast motion, just like so. So that's the animation I want you to visualize in your mind as we work out the problem to get our final velocities of negative 6 meters per second to the left and 2 meters per second to the right.
Alright, so when we answer this question, we first want to put our knowns and unknowns, and we already can visualize exactly what's happening. We have the red cart going 6 meters per second to the right, and the blue cart going 2 meters per second to the left. We know what their mass is, so now we can put our knowns. So we want to say that our knowns are M1, which we'll say is the red cart, is equal to 1 kilogram. We'll say our V1, the velocity of the red cart, is 6 meters per second. Now by saying it's 6 meters per second, we are saying positive direction is to the right. So I'll draw that, I'll draw a vector like that, and we'll label it as positive direction. We always have to choose what our positive direction is. So we'll say to the right is our positive direction. What else are our knowns? Well, our mass 2, we'll say is the blue cart, so the mass 2 equals 3 kilograms. And now this is where we make some mistakes. Our velocity 2 is not 2 meters per second. If we look at our velocity vector, it's going to the left. So the left velocity vector is saying the direction, and the 2 is saying the magnitude of the velocity. So since we can't use arrows when we're doing our arithmetic, when we're doing our computations, our arrow takes the place of the negative sign. So that negative means that the velocity is going to the left, just like the blue arrow denotes in the illustration on the top. So we have a negative 2 meters per second. That's saying that the velocity of the blue cart is going 2 meters per second to the left. The negative means to the left, the positive means to the right. Okay, and these knowns are before collision. So we could say before collision. Okay, now what about after the collision? What happens after the collision? Well, we have our M1, they split apart, so the M1 is still 1 kilogram. Alright, the final one I will give you, I will give that to you as negative 6 meters per second, which means that the velocity is now going to the left. It's a negative velocity. Our mass 2 stays the same, 3 kg, that's the mass of the blue cart, and VF2 we are going to find, so I'll leave that as a question mark. So how are we going to find VF2? And we're going to say that this is after collision. Okay. Well, in order to find the velocity final of the blue cart, we will use the equation P before, or momentum before, P before equals P after. Okay? And what this is saying, it's saying what is the momentum before of the object. So what's the momentum? So it's the momentum of the red cart, so I'll say momentum R, plus the momentum blue equals after P, we'll say final R plus P final blue. Okay, that's what it's saying. And we can think of the equal sign as the collision. So what is the momentum of the red cart before the collision? Well, it's M1 times V1 plus what's the momentum of the blue cart? M2 V2 equal to the momentum of the red cart, the final momentum, which is M2 VF2. I'm sorry. M1 VF1 plus M2 VF2. Okay, and now what we basically have to do is we have to substitute the information in. So M1 was 1 kilogram. V1 is positive 6 meters per second. And that's added to M2, which is 3 kilograms, times the velocity 2. We said the velocity was a negative because it's going to the left, so it's a negative 2 meters per second. And that's equal to M1, which is 1 kilogram, times the final velocity of 1 after the collision, which we were given as negative 6. You'll always be given the final velocity of one of the carts in these problems where they split apart. So that's negative 6 meters per second. And that's added to the mass 2, which is 3 kg. And we are trying to find VF2. Okay? Alright, so we can see that we have 6 kilograms meters per second plus a negative 6 plus a negative 6 kilogram meter per second equal to a negative 6 kilogram meter per second plus a 3 kilogram VF2. So we get 0 kilogram meter per second equal to a negative 6 kilogram meter per second plus 3 kilogram VF2. So we're going to bring over that 6, so we're going to add a 6 kilogram meter per second to the other side. Again, we're able to do that because the units work out. We have a kilogram meter per second. And we get 6 kilogram meter per second on the left-hand side equal to 3 kilogram VF2. Okay, we divide by kilogram, 3 kilograms. We divide by 3 kilograms. We can see that the kilograms cancel, and we are left with 2 meters per second. It's the correct units, and that is equal to our V final 2, which is the final velocity, or the velocity of the blue cart after the collision, is going 2 meters per second in what direction? in the right direction. So we'll say 2 meters per second, and this is right, or velocity vector that way. Okay, a negative would have told us that it was going to the left. A positive tells us that it's going to the right, and we know that this is correct because we verified it with our animation.